And then what we're going to do right now, the math. So those are the two things that are up, and everything has today's date, but it's due on Friday. So you can, plot your time how you want to. Of course, this one about the film is due. We're just going to keep talking about it throughout the week if you watched it and bring up some other points. Of course, ecosystems is throughout the week. And then for math, in the instructions, it's a little bit of a different breakdown. So there is the area of composite shapes within Khan Academy to help you with this first part of the section. And some people have already done Study Jam's composite shapes, but you can, of course, do that as well. So all we're really doing is from page 242 to 244 today. So this assignment, or I should say this PDF, I will just upload it again because I think that might be confusing for people if they're missing the live class, that we're just really, I'm uploading the entire section like we kind of voted on, but I think some people were not in the vote. So it might be confusing. So I'm just gonna put more specific instructions of the pages that we actually are going through to help the people who need a review or who can't make the class. So what we're doing is just the beginning, and it's a review of everything. So it says perimeter, area, surface area, and volume, but now we're doing the composite figures. So the objectives: calculate perimeter and area of 2-dimensional composite figures, calculate surface area and volume of 3-dimensional composite figures. So this is kind of a review of everything of those first formulas that we learned, but now, and it's a review of 2-dimensional and 3-dimensional. Now we're on, what is a composite figure? A figure that is made up of 2 or more shapes. A composite solid, an object that is made up of 2 or more solids. So now we're just saying the same thing that we were doing last week, is looking around at things in the world, whether it's like the tanks on the side of the highway was one of the examples, or a house that might be, rectangles and pyramids, or maybe rectangular prisms and triangular prisms. But whatever you're looking at in the real world and inside of your house, you're looking to say, what are those objects made out of? So what are the figures and what are the objects made out of? And breaking it into as many pieces as you need to. So the vocabulary is also 2-dimensional, which we already know, 3-dimensional, and then hemisphere, which we did talk about this a couple of times. So we said this word last week when we were on sphere, but hemisphere is half of a sphere. So we're gonna look now. The key concept is to find the area of a composite figure and add the area of each figure in the composite. To find the perimeter, add pieces of the perimeter of each figure. Similarly, to find the volume of a composite solid, add the volume of each solid. To find the surface area, add parts of each solid's surface area. So I think that that's pretty straightforward. The only thing is that you're just reminding yourself what are the shapes that you can think of. So in this 2-dimensional section, it's starting with perimeter. So I think that we did this pretty well when we did perimeter, because we did it on Math is Fun and it had some different kinds of shapes. But what you want to do, what we said when you're doing perimeter, is find a place where you want to start. So I just recommended starting at 12 o'clock because you can do that all the time. You can do it with photos and science and charts, and you can do it with like the political cartoon and social studies. So I think like 12 o'clock is just a good starting point. But of course, you want to do what feels natural to you, and you want to do the same thing all of the time. So if I start here at 3 centimeters at 12 o'clock, I'm going to just go clockwise and go back around. So what you just don't want to do is you don't want to start a different place every time, because then you'll be lost, right? You'll be like, did I count to 2? Did I count to 3? And then you have to start over. So in an effort to make sure you're focused, you want to just train yourself to do the same thing all the time. So this one is saying, when the composite figure is composed entirely of straight edges, add the side lengths to determine the perimeter. So that is pretty straightforward. This is the exact one that we did on Math is Fun. You're just starting here and you're going every straight line and adding it up. So they decided to go 3, 2, 1, 3, 2, 3, 2, plus 8, and then you got 24. You're gonna go, like we said, however you want to. I would have gone like this, 3, 2, 3, 2, 8, just because I'm gonna go clockwise. In this figure though, there's a semicircle. So when the composite figure includes a semicircle, you add the lengths of the straight sides and the circumference of the semicircle. So what you're thinking about is that you want to go around the border still, because you're talking about perimeter. So this is what we were saying could be a half court, or it could be a swimming pool or a table or something like that where you have a semicircle. You're going to do half of pi times the diameter because you don't have the whole circle, you only have a semicircle. And then here, this is the diameter. So where it is labeled right here as 14 centimeters, you know that you're going to use that 1/2 of pi times 14. That pi 14 is pi times the diameter. So even though it's not labeled, you're borrowing that from the other side because you understand, you know, the rule about the diameter being the same as the rectangle shape. So I think the perimeter is straightforward. You just have to say to yourself that you are counting 120, 114, another 20, and then the semicircle, however you're gonna figure that out. So you can figure it out pi times diameter and then take half of that, or you can do 1/2 times pi times the diameter. And that's why they also have the wavy equal signs, oops, again, because it's about 76 centimeters. So now for area, and this is what the Khan Academy video is about, you have to do the same thing. So they have the same two shapes, but now they're saying, how can you look at the shapes and decide what the one shape is actually made up of? So for A, they're saying, oh, I see 1, 2, 3 rectangles actually. So if I have to do the area of this figure, I might as well say length times width of the first rectangle I see, length times width of the second rectangle I see, and then length times width of the third rectangle, and I'm gonna add those up. So this is the formula that they're making for themselves. A equals a length times width plus a length times width plus a length times width. So you have to figure it out. Now, this one is where you might have to use your imagination again, or you might have to take a look around the shape to see what the length and the width actually is. So here, this one is 2 across and 3 down, so that one's pretty straightforward, right? But this rectangle right here, you might be like, I don't know how high this one is. So this one's definitely 3 across, but now how tall is it? You have to say it's 3, like the other one, but then it is plus this 1 right here. So this length is actually 4 times 3. And then this one over here is labeled, it's 2, and then it's 3 across. So you have 3 times 2 plus 4 times 3 plus 2 times 3, because you're imagining it as 3 different rectangles. So now this also you can do like they did, or you can do it the other way. However you see the 3 shapes, but you definitely, if you get a composite figure, want to decide what are the shapes that you're looking at and then add them all up as the area. So likewise, for the one with the semicircle, you're saying that in order for me to get the area of this shape, I have a rectangle that I have to figure out the area is length by width. And I have a circle or a semicircle that I have to figure out pi r squared and take half of that because it's only a semicircle. So there's a 14 and a 20. They have 14 times 20 for the rectangle. And then they have, if this is 14 as the diameter, the radius is going to be 7. So 1/2 pi times 7 squared. And it's about 357 centimeters. So you're making that decision again of what are the shapes that you're looking at, and then how are you going to solve them? So what formula, first of all, what shape is it? And then what are the formulas for that shape? And do you have to make an adjustment like this one and just say half? And then at the end, you're adding everything up. So what we're going to do right now is the think about math. So hopefully this is not too bad of a photocopy. This first one is a little park. It's saying Farah is going to run the trail shown. So what she's running is the border right here, which you can say is like a little trail around the park. So what is the distance that she will run? Round to the nearest yard. So take 2 minutes and let's see how many people are here. I will put you in the breakout room so you can discuss it. All right, so you can go into the breakout room and just talk about your approach to talk it out, and then we'll come back and go over the answer.
What is the distance that she will run? Round to the nearest yard. And it's kind of like the same figure that she showed before. It has like a little square and a semicircle.
Yeah, I mean,
Yeah.
semicircle, yeah.
Yeah, so it's 600 yards and 800 yards. So we have to add pretty much both of the perimeters. But I don't know exactly where the semicircle starts. I can barely see that in the copy.
Okay.
Trail, show what is distant, run around the nearest yard.
800 yards, you subtract the 200 yards in between. You don't know.
What I'm saying.
800. I'm not doing it.
This is what my teacher assigned me. Class.
Greetings, everybody. Welcome back.
We were a little lost.
It was a loss.
Okay. Well, I'm going to try to draw this out.
Okay.
So you've got the semicircle, oops, and a rectangle.
Okay.
And a trail. So basically she's just going around that. There's like some trees. So what they're trying to get you to think of is just going around the rectangle part and one part of the semicircle. So you've got 600 and 800. So did you think of which formula you would be using?
Is it multiply and then half?
The perimeter formula of a rectangle.
So it's going to be perimeter formulas because it's just a trail.
Right.
So that's the first thing you're thinking of. I got a rectangle and I got a semicircle, but now out of those flat shapes that we knew, you're still going to ask yourself, is it perimeter or area? So just like with the three-dimensional shapes, when we get to that, you're going to first say, what are the actual shapes that I have? And then do I need surface area or do I need volume? So you're still thinking about identifying the shapes first, of course, but then through the story, especially if it's not a straightforward problem like find the area or find the perimeter, you have to make the decision based on what's happening in the story of a word problem to pull out the formula. So because this is perimeter, we're saying P equals, now just doing the rectangle, you're gonna have 600 plus 2 of the 800, because we're gonna go at the top and at the bottom. So in this case, it's not labeled, but you're assuming that up at the top is also at 800. Plus, to do the semicircle, again, just the rule of the rectangle would be that the diameter would be the other shape or the other side. So right here is going to start the semicircle, which is just the 600 from the other side. So kind of just like the example number 2, where we copied 14 over as the diameter of the semicircle, we're going to copy 600 over. So we're saying 1/2 pi times 600. So this is what you needed to figure out for the perimeter. So first you're just saying you're going to do the 2 times 8, which you don't have to do it this way. You could have added it up because it is perimeter. But either way, you're saying that the rectangle is 600 plus 1600. And then 1/2 of pi times 600. This is like a, an estimate depending on what you use for pi. These are the 3 things that you're adding up. Or if you added up all 3, like 1600, 800, 800, and 600, then you might have 2 things that you're looking at adding up. Any questions so far? So, and this is again about, so you can do the wavy equal signs actually. So this is what you should have, that you added up 3 sides for the rectangle and half of the circumference of that circle. So the thing that you have to know for this one is that the diameter is going to be, you have to copy the 600 over as the diameter and copy the 800 over as the top part of the trail to complete the perimeter.
Miss Hugh, I'm sorry, I have a question. So you're saying that the 600 is the diameter of the circle in this case?
Yes. So let me go back to the picture.
Yeah, because in the problem, I was kind of confused as to how to get the radius out of the problem. So
Yeah, for
I
this
still
one,
don't understand.
because of now the trail, the picture is a little fuzzy because it's a scan. Can you see this one?
Yes.
Okay. So what you're saying is just following the rules of the rectangle. What this length is, or if you're calling this the width of the rectangle, it's automatically going to copy over on the other side of the rectangle. And that by default is the diameter of the semicircle. So let me see if I can go to where we looked at it on Math is Fun. I don't think that they have a good picture. Well, we're just going to look at rectangles. So the idea is that the rule of a rectangle is that you've got these parallel sides. So what you're saying, the same way that you have 800 yards on the bottom and what's parallel is going to be 800 yards on the top, the 600 yards on the left are parallel to 600 yards on the right. So in order to think about perimeter, you're saying 800 plus 600 plus 800, and then when she starts to go around the semicircle, the diameter of that is going to be the same as the parallel side of the rectangle, which is 600. So you have to say to yourself, you're doing pi times the diameter, pi times 600, but you only need half of that.
So it's going to be 91.
Well, let's see. I put mine all together in the calculator. But what you're saying is 3.14 times 600. So if you just did the circle first and got 1884, then you could say divided by 2 is 942. So I put 942.45, but I might have used the pi button. Maybe I was rounding a little bit. Or sometimes I type in 3.1415. Yep, that's what I think I did this time. I typed in 3.1415. So like what you don't have to worry again, because like we said, the majority of your questions are multiple choice. Just so happens that these two are not multiple choice. So, but what you're thinking is I'm gonna, borrow the bottom number for the top. I'm gonna borrow the left number for the right. And it's the same idea as the example, which when we saw this one is saying that, now this was area, right? So this one was talking about radius, but if we go back to the first page, you can see they did pi times 14. So you're copying what is on the left because you're seeing it as two separate shapes. So what would have happened is the rest of the circle would be right here inside of the rectangle, but we don't need that part because it's not the complete circle. And the person is gonna run across the top, across half of the circle, across the bottom, and across the left. So you're just using the regular circle formula, which is pi times diameter, but you're saying to yourself that you know you only need half because it's just a semicircle. Does that make sense?
Yes.
So the picture's not so good. I believe it's supposed to be like a park, so like this thing over here might be one of those little spinning things that children get on. These little things are supposed to be like some trees and that type of thing, but the trail that she's running is this white part that's going around. So you were supposed to pick out perimeter and recognize that it's a rectangle and a semicircle. Now, if this was 600 and the bottom was 600, then you're recognizing it's a square and a semicircle.
Okay.
And, depending on how they might be talking, they might say that. through the description. So that's what you're like, this does have a diagram and so does number 2, but you're still thinking about the story part of it. So in number 2, it's shifting a little bit because it's saying that he's painting. So now you're already thinking of which formula would it be painting, but this is what his room looks like. So Ben is painting the interior wall of a room with the dimensions shown. What is the area of the wall to be painted? Now this one is straightforward because it's telling you, it's asking you what is the area. So you should be saying to yourself, I need area formulas. And now you're trying to identify what are the shapes that make up his wall. So I'm going to put you in the breakout room one more time. And you can discuss how to get the area. right, so who wants to talk about what you discussed?
Nominees.
Don't everybody go at once.
We're just
No.
trying to copy.
So we kind of already have area, right? What did you talk about in your group?
First you do the rectangle
Mhm.
formula.
So great, we got a rectangle. Did you come up with the area for the rectangle?
Yes.
So what did you get?
140 square
Perfect.
feet.
Oops. And now you have to do the triangle, right?
Right.
Did you come up with the area for the triangle?
Yes.
What did you get?
49.02.
It's a little less. So what did you say was the height of the rectangle?
16.34.
The height? I'm sorry,
Yeah.
of the triangle.
A triangle. Right. Well, what we did is that we used the Pythagorean theorem to get the missing side of the triangle.
Okay, you're getting fancy in that group, huh?
So, so I don't know if that's how I made a mistake there, maybe.
That was really fancy of you. You don't have to do that.
Oh, we don't have to do that?
No, luckily,
So we're
I know
doing a little
that
more.
I might have led you to that by saying every time you see the right triangle,
Oh,
you might have to
Yeah,
use the
no,
Pythagorean
you're
theorem.
right. You're right, because we got the 14 feet on the other side of the rectangle, so
Exactly.
it's the same. All right, so then
So
we're
for
wrong.
this one, you can say to yourself that this right here
This is 10, then that's 6.
is 14,
14,
and
So
this right here would be how much?
6.
Right.
Right.
So you really just have to say
14 times
7 times 6, because you're going to take 1/2 of the base times the height. So this formula you can kind of probably do in your head because you got the number 14. If you're doing the mental math style of saying 1/2 of the base is 7, and then times 6, you could just say 140 plus the 42. And again, if you were getting fancy, you would still come out with something close that in multiple choice, you know, can figure out the sides, but this one you probably could just do subtraction. So because they're telling you on the outside that the whole thing is 16, that's a clue that you can subtract 10 from the 16 and just know that the A side of the triangle is 6. Now that 15.2 is thrown in there that you don't need, right? So that's something to ignore, really. Which sometimes, like we said, that you have something, or you might have one figure labeled for more than one question, and maybe sometimes you don't need all the information, right? So in this case, knowing that you're just trying to do area, you're looking for the base or 1/2 the base times the height. So you need a base number and you need a height number. If you can identify it in an easy way, then you can ignore the 15.2. So you're just coming up with 182 as the area for the second figure, or for number 2.
Pretty close.
So that's a good work in your groups, discussing, which shapes you have and what to do with them, right, based on the question. We're going to take a look at this one that's in the core skill, so it's just in the margin. It says ceramic tiles are commonly used for kitchen and bathroom floors. Oftentimes, the tiles are sold by square foot. So it is necessary to calculate the area of the floor to be covered in order to determine how many tiles are needed. The figure represents a section of floor. What is the area of this floor section? Explain how you found your answer. So this one, what are we looking at? We're going to do this one together.
A rectangle again and a semicircle.
Right, so this one's just a skinnier rectangle, right? So again, we're thinking of area, so we should be looking at thinking of area formulas.
Let me go through.
Clear this one. So we've got a skinnier rectangle. So how are we figuring out the rectangle and the semicircle? So we've got, what would be the area of the rectangle?
One more time.
Width length times width.
Exactly. So we've got the rectangle is going to be length times width. We've got a 10 and a 4. So 10 times 4 is 40. Now for the semicircle, we need to do the area. So the area of a circle is pi r squared. Right? So now we're going to remember that to do the semicircle, you need half of that. So what is the radius?
The radius would be 5.
Yes, so we're just doing pi 5 squared, or pi 25. And then we're saying 1/2 times 3.14 times 25. So I have about 39. But it depends on what you're using again. Are you using 3.14, 3.1415, the pi button? But basically what you want to say is somewhere that the semicircle is about 39.3. And again, yours is going to be probably, more than likely it will be multiple choice. So what you're really doing is adding these two up because it's a composite figure again. So if you can identify a rectangle and identify a semicircle, at the end, when you find the areas, you have to add them together. So your answer is going to be 79.3. Any questions about this one?
No.
Okay, so last but not least, we're going to flip over to the next one that's in the margin. And this will be the last one that we do for today. So if we flip over one more page, we're going to do this one, which is a silo. So this is what we were saying that you actually might see, kind of like the ones for water or for gas that we said might be a hemisphere on top of a cylinder, or different kinds of shapes. But this one is in the financial, economic, business, entrepreneurial literacy. So you might actually have a question like this in the attempt to be real life, right? So when farmers harvest grain, they must have a place to store the grain until they need to use it. Many farms have a building called a silo to store grain. When constructing a silo, the volume of the building is a measure of how much grain can be stored in the silo. A farmer is constructing a grain silo for his farm with the dimensions shown. What is the approximate volume of the grain silo. So now we're looking at this figure. You're going to do the same thing. But now you're thinking this is volume because they're actually going to put something inside. So you need to make sure you find the volume of the two shapes that you identify. And we're going to do this one in the breakout and then come back together in about 3 minutes. And you can tell me what you came up with as the volume. All right, so do you have an idea?
We all know is that we need the volume formula for a cylinder and I think a cone on the top.
Yes, that's correct. So this is not a very good drawing, but you get the idea. So So I'm just gonna say this is not drawn to scale, as they always say. So you need to have the volume of 2 figures. And you're right, it's a cylinder. If it's a cylinder on the bottom, then it's gonna be the cone at the top, right? So just like if it was a square or the rectangular prism, it'd be the triangle, pyramid, or triangular prism at the top. So this is coming to a point again, but it's on top of a cylinder, so that makes it a cone. So you need to have a cylinder. Does anybody remember the volume formula for cylinder?
Isn't it, for cylinder, is it pi, radius, height?
Right.
Yep, so it's the circle with height. So pi r squared height. So for that one, what is the radius?
No idea.
So let's see.
Let me see. I'll tell you right now. Let's see. Let's see. Don't tell me yet. 10 times 10.
This is the challenge, right?
No, it can't be 15. It can't be.
The radius is 20. So you're borrowing it from the top, understanding that from the point to the middle, right here, from this point down to here would make the middle of the circle.
We have.
So this dashed line where they have 20 coming off of the shape, that's the radius.
I can't.
Basically, it already did it. It already did the 10.
I can't see those things.
Yeah.
It's kind of hard for me to imagine all
Yeah,
that.
it's, that's the key, right? So now this is because, and you are looking at a scan, right? So what you're supposed to say, there's a lot of dashes going on because they're trying to make this a 3D shape. This little dash in the background is a circle right here to have you say, yes, this is a cone and this is a cylinder. This dash coming down is marking the middle where the 10 feet is showing height. And these are the right pyramids, right cones, which means they're perpendicular. That's why they have the little box. This is going to make a right angle. So this dash is only halfway. It's not going all the way across. So the 20 is not a diameter. It's just a radius. So because it's already marked as a radius, you don't have to do anything else. You're going to use the number 20. So you're going to say pi 20 squared. And then what did you identify as the height?
Tricky.
15. Because this one, we're only talking about the cylinder so far.
Oh, that's what I said before. Okay.
So now you're saying 20 times 20.
400.
And now you can do the, like we said, a lot of times you can do pi last. So you're just going to say 400 times 15. Sometimes pi is in the answer.
6,000 pi.
And then you can do the wavy equal signs depending on what you use for pi. That's my approximate volume. So if you came anywhere close to that, you've got the cylinder, right? So we've got the base. We can hold that number. And now we're going to add it to the cone. So the cone, we need the volume. And what was the formula for volume of a cone?
Vector times pi times r
Exactly.
times height.
It's 1/3 of the cylinder, right? So 1/3 pi r and then the height. So now you're saying you already know the radius because it's the same. But what is the height of the cone?
The height of the cone is, no. It's 10.
Yep. It's 10. So now you're just doing the order of operations. 20 times 20, we already did. It's 400. Now this time times 10. So now you have 4,000. And same thing, you're saying to yourself, times pi times 0.3333, however many threes you want to use. So I have approximately 4,184. So I think whatever numbers I used, I got 0.47. But as long as you're kind of close to 4,184, that is the number that we're adding to the cylinder. So it's these two that we're saying makes this about 23,033, 34, 35, 36, 37, 38. Anywhere around there, because it depends on what you use for pi. And also because we're shifting the 1/3 to a decimal, it depends on if you say, I would at least use 3 threes if you do the decimal. So at least do 0.333. So because these are all approximations, we're gonna say it's anywhere from 23,033 to like 38. If you got anywhere there, that means you picked out the right two shapes, you picked out the right two formulas for those two shapes, and you did the order of operations, and then you added them up correctly. So what we're gonna do is just look at the page, and then you can go, you know, if you have time still today, you can do what's listed in Google, or you can do it in the morning. We just did this assignment, of course, the margins and the 2 examples. But if you also have time to redo composite figures on study jams or to take a look at it on Khan Academy, then you can do that for the rest of math. So we did this already, but this is just the description of talking about what we just did with the silo. So this is just saying volume of 3-dimensional solids, and the example is a square with a pyramid. So this is what we just did, but we did it with the cylinder and the cone. But it says find the volume of the figure. So you can get a question that's really direct like that, or one that's more of the story, like the shape being a silo for the farm, right? So step number 1 is always to identify the shapes and the formula. So this is saying identify the solids that make up the figure and the correct formula for volume of each solid. This composite solid is made up of a rectangular prism and a pyramid. So they've got the prism is going to be length times width times height. And you're looking at this saying it's a square, right? Because it's 9, 9, and 9. So it's a cube. Now in step number 2, you're substituting. So the 9 times 9 times 9 is going to be the cube. And then you're looking at what can you get out of the pyramid. So you're saying that the pyramid is 1/3 of the cube, just like the cone is 1/3 of the cylinder. So now you just need to say the length and the width is going to be the 9 that you're copying from the cube because it's right on top. It's flush and even. So you're going to borrow those same numbers. The only thing that's different is that the height of the pyramid is the dashed line down the middle again. So that one is a 6. So this is saying 9 times 9 times 6, and then you're remembering to take 1/3 of that for the volume of the pyramid. So you have, add them up together, and you get 891 cubic inches. So this is what we just did today. We did a little bit of the volume of spheres and cylinders because we did the one that's in the margin, but the idea is always to identify the shapes and make sure you pick out the right formulas for perimeter, for area, or for volume. So what we're gonna do tomorrow is just take a look at like what we just did and do the semicircle, or I'm sorry, hemisphere and cylinder in example number 4. There's another think about math. And then there's prisms and pyramids for example number 5. Example number 6 is getting on to surface area. So we're gonna do those 3 tomorrow and this one in the margin. And then by Wednesday, we'll be on the vocabulary review, skill review, and skill practice. So that might take us, depending on how it goes, might take us 2 days. But as you can see, because we already know the formulas and already know the shapes, this one's moving much faster than the last section. So what we're gonna do is, if we're done on Thursday, that means on Friday, we'll go to the task exercise book and kind of treat that one like a quiz. So our focus is to do science and to do math this week. And I think next week, I might have it up this week actually. If you still want to write, you want to do any essays or anything, I think maybe I'll put it up by Wednesday, and then it could go over the weekend also, just to give you time. So if you're looking to, if you still have to do the writing test, there'll be another sample of something to read, and then you're testing yourself, can you get done in 45 minutes, like the goal that we had for class. So if you have any questions about Khan Academy, just let me know. I'm also going to put up the tab for Aztec, so you can always do Aztec. I would recommend doing at least one lesson of Aztec, like logging in every day just for the practice of it, because eventually you can do those practice exercises. So anything that you have a question on, you can take a picture and send it to me on Remind. And if you don't have any questions, we're just going to go over those next couple of examples in math. And I will send you, I'll put up the links for the drone footage also. So we're going to just get to learn the first 3 ecosystems, and then we'll move to the aquatic ecosystem. So we're just on land now, grasslands, deserts, and tropical rainforests. So maybe you can meditate while you watch the drone footage. I'm trying to pick out something that's short, but still pretty. So let me know what you think. If you're a person who still has science to do, you can make a comment on Google under, under that assignment of the drone footage. And then of course it's going to be on YouTube, so you can find some others, but you're just trying to put that in your mind again. When you read the words like rainforest or desert or ocean, that something comes up in your mind. So the purpose of watching the videos, which I sometimes like better than books anyway, is that it gives you a memory. That's what you're drawing from when you go to do the science section. If they talk about the mountains, the rocks, the water cycle, as some image comes into your mind. So we're going to use this footage because I love drone footage. It's vast and you get to see a lot more than what you would normally see on the ground level. And then hopefully that will be a good enough imagery for you to think of every time you think of these 3 ecosystems. So of course I want your opinion. Let me know what you think. And on that note, we're done. Anybody have any questions?
No.
So happy Monday.
Thank you,
Let me
Ms.
know if anything comes up in the assignment. And if not, I will just see you tomorrow.
All right.
See you tomorrow.
Thank you.
All right,
Thank
see
you.
you.
Have a good day.
You too. All right, Kaven.